Hello Dr. Devik, I'm Ahmed Sajid and today me and my groupmates will be presenting on electrostatic precipitators. Along with the amazing technological advances, the Industrial Revolution of the mid-19th century introduced new sources of air pollution. By the middle of the 20th century, the effects of these changes were being felt in countries around the world. Most power stations burn fossil fuels such as coal or oil to generate electricity for use. When these fuels undergo combustion, flue gas is produced and the products typically consist of smoke, fly ash, and heavy ash. It is vital to remove this unreacted carbon from the smoke as it can damage buildings and harm people, especially the respiratory health. Therefore, to combat this problem, electrostatic precipitators are used in many industries such as manufacturing, metal, and mining industries, where they are installed as part of the flue gas cleaning system. So, first and foremost, let us know what is an electrostatic precipitator. Originally designed for recovery of valuable industrial process materials, the electrostatic precipitators, also known as ESP, is an advanced air pollution equipment that works on the principle of electrostatic precipitation. Here, static electricity is used by applying a static charge to dot particles in the air and then collecting those charged particles on a plate or collector of the opposite electrical charge. The main purpose of an ESP is to avoid harmful particulates being expelled into the atmosphere where they can cause pollution. It can capture the finest of dust particles that are liberated by various industrial processes using the force of an induced electrostatic charge, minimally disrupting the flow of gas through the unit. Moreover, it has a very high efficiency nearing over 99% and can achieve an emission level of less than 10 milligrams per NMQ. It has a very low pressure drop of less than 20 millimeters water column. Electrostatic precipitators usually have a rectangular shape with dust collecting hoppers installed at their base. The main components of an ESP consist of collecting electrodes, discharge electrodes, inlet and outlet perforated screens, insulators for the discharge electrodes, wrappers, and several electrical transformers. Currently, there are 4 basic types of ESPs, which are plate and wire. Those are dry. Plate, those are also dry. Wet ESPs and 2-stage ESPs. Next, I would like to also share a little history about electrostatic precipitators. In 1907, American chemist Frederick Gardner Cottrell, professor of chemistry at the University of California, applied for a patent on a device for charging particles and then collecting them through electrostatic attraction. The term used for the migration of gas-suspended charged particles of a direct current electrostatic field was known as electrophoresis. Cottrell first applied the device to the collection of sulfuric and mist and lead oxide fumes emitted from various acid-making and smelting activities. The application of statics in an electrostatic precipitator is that it is a rigid body mechanics in the area of statics where it deals with the equilibrium of bodies as it remains at rest because acceleration is zero and the ESP is designed to remain in equilibrium. Moving on, now I'll be discussing how an electrostatic precipitator actually operates. So factories are equipped with smokestacks that let smoke and combustion gases escape. This is where the electrostatic precipitators work by forcing the dirty flue gas through 2 electrodes that are fitted against the inside wall of the smokestack. When high voltage is applied on electrostatic discharge takes place across the stack, and as a result the air in the stack gets ionized. That consists of ions and free electrons. Eventually the free electrons get attached to the gaseous particles, and while moving up the stack, the particles get negatively charged and are attracted to the positive electrode on the inner wall of the stack and settle down there. These can be later dislodged from the electrodes by vibrating the electrodes and are collected in a reservoir. Therefore, almost 99% of the particulate matter gets removed from the harmful flue gases in this way. So that is all for my part. I'll be passing it along to Michelle. Thank you.
Hi, I'm Michelle, and today I'll be discussing about the advantages of electrostatic precipitators. Electrostatic precipitators are widely used in this day and age as the concern for environmental pollution has tremendously increased. Electrostatic precipitators are similar to air filters, cyclones, where they are all air pollution control equipment used to collect and purify the air by removing fine particles such as dust, soot, and ash from exhaust gas streams. An example of the usage of electrostatic precipitators can be seen at power generating stations where they burn fossil fuels to generate electricity. When combustion occurs, smoke is released into the air, and this is where the electrostatic precipitator collects the tiny particles of soot from the smoke and filter them by using static electricity. It is very beneficial to install this equipment as it helps control air pollution and eliminate harmful dust particles. The advantages that I'll be discussing today are the high efficiency of the removal of pollutants, how the electrostatic precipitator are highly effective, the low operating cost, and the collection of both wet and dry pollutants. The first advantage, which is the electrostatic precipitator have high efficiency of the removal of pollutants. There are many factors that affect the efficiency of the electrostatic precipitator. Some examples are the corona power ratio, the resistance of the particles, etc. Under normal circumstances, the efficiency for the removal of particles is very high, where it can remove up to 99% of pollutants, such as dust and soot particles, with minimal wastage of energy, materials, effort, and time. Over a wide range of particle sizes, the electrostatic precipitator has a high efficiency collection. The next advantage that I will be discussing is the fact that electrostatic precipitators are highly effective, as it is successfully capable of removing 99% of particulate matter. Since the year 1940, particulate matter of 10 micrometers or smaller can be reduced to 1/5 of its original particle size of pollutant. This proves that electrostatic precipitator really is beneficial in reducing the level of air pollution. Other than that, electrostatic precipitators have low operating costs and are easy to operate. As the operating costs are low, it makes it easy for power plants all around the world to install and make use of this air pollution control equipment, as it is an affordable option compared to other air pollution control equipment. This low operating costs contributes to the electrostatic precipitator being economically feasible in the long run. Not only that, but this equipment is also a good investment, as it is able to last and work well for a long time with minimal maintenance required. Lastly, the fourth advantage is the collection of both wet and dry pollutants. There are two types of electrostatic precipitators, which are the wet and dry. The difference between the both electrostatic precipitators are that the wet substances such as oil, tar, paint, etc. uses the wet electrostatic precipitator, while the dry electrostatic precipitator is used for collecting dry pollutants such as cement and ash. The separation of the wet substances and the dry particles are beneficial to ensure the effectiveness of the electrostatic precipitator. Thank you.
Hello, my name is Kian Ming, and now we will continue on to the disadvantages of the electrostatic precipitators, also known as ESP. Sadly, the ESP, instead of mechanical design, which uses gravity, only works using electricity, in which Malaysia only provides 18% of energy using renewable energy. Before purchasing an ESP, a decision to use either wet or dry must be made. The ESP is very large and difficult to install because it requires a low gas velocity. To achieve higher efficiency of it extracting pollutants, the ESP machinery or its electric field needs to be bigger. Due to its size, flexibility within the factory is nearly impossible. Efficiency-wise, particulate pollutants smaller than 10 micrometers and all gaseous pollutants cannot be collected by the ESP. The ESP also needs a long-weighted wires to deliver current for ionization. These wires will oscillate and then cause wear and tear, as well as sparks as they hit onto the main body of the machinery due to it not being fixed. During the ionization process, the ozone will be created. Ozone is only beneficial to humans at the atmospheric level, but on human breathing levels, ozone will cause lung damage, and many ozones in our vicinity will actually cause smog, which is smoke and fog. For dry ESP, it will require manual removal of the collected pollutants, while wet ESP will have its collector walls sprayed with water, washing off the collected pollutants into a drainage system that will drain it. However, that water will become toxic water wastage. For every ESP, you will need to hire a sophisticated worker to operate it. Because, have you heard of transformers? Sadly, it isn't about the ones in the movie, but an ESP will need one. A transformer can either increase a voltage or decrease one. In our case, the ESP draws power from a factory power outlet of 220 volts and increases it towards 20,000 volts. Fun fact, just 30 volts is already capable of damaging the human body. So ESP is very dangerous due to high voltages and the sparks. Next, it is high maintenance as it requires frequent maintenance of due to the electrodes, the air leakage, and acid condensation that will cause corrosion inside the machinery. The standard size of an ESP will be around 20,000 square feet. This size would normally cost you a capital of $85,000 and an annual cost of around $37,000 for operation and maintenance. The price would increase significantly for a wet ESP as it will require better corrosive resistant materials such as titanium. Above were the mentioned disadvantages, but fortunately, as engineers, we can see solutions to our disadvantages. The price of getting one can be reduced with subsidies from government, as it is not only industries who are responsible for environmental protection. Future ESPs are replacing the wire electrodes, the ones that are not fixed, with a fixed rigid electrode to prevent wear and tear and sparks. Current ones are just too difficult to replace it due to the inflexibility. Our current technology, surprisingly and very nicely, also helps us treat the drain toxic water wastage, which we can recycle them and we can reuse them in the machine, causing zero water wasting. In conclusion, I would like to refer to Mark Zuckerberg and the movie The Martian. So Mark said that getting it done is more important than getting it perfect. So right now, what we have is the best. And in The Martian, it shows us what engineers are supposed to be, solving one problem after the next. Hence, we will solve the next problem and any ESP brings up. Thank you for your time.